Hi students, in today's session we are going to discuss the topic nuclear fusion. We are going to discuss the topic of nuclear fusion as two parts. One, nuclear fusion in stars, and the other one about fusion reactors. In this video, we are going to discuss in detail the nuclear fusion reaction taking place in stars. As you all know, the process in which two lighter nuclei combine together to form a heavy nucleus with the release of enormous amounts of energy is called nuclear fusion. Now, the energy radiated by the sun in 1 second is an enormous amount of 4 into 10 raised to 12 watt per second. And an area of 1 meter square of the earth, when exposed to the vertical rays of the sun, receives energy at a rate of 1.4 kilowatt per meter square, even though the sun is about 150 million kilometers away from us. So, what is the process responsible for such a huge amount of energy to be produced in the sun? It is the nuclear fusion reaction. In our sun, the nuclear fusion of hydrogen nuclei to helium is taking place. Now, the process by which hydrogen nuclei fuse together to form helium can take different reaction routes. And the most common one is the proton-proton cycle. Here, the total energy released is 24.7 MeV per helium nucleus. So let us discuss the proton-proton cycle. Here, two protons combine together to form H12 nuclei with the release of a positron. This H12 combines with another proton to form an He23 nuclei, He23. Here again, one more set of protons fuse together to form an H12 nuclei with the release of a positron, and this H12 nuclei combines with another proton to form an He23 nuclei. These two He23 nuclei fuse together to form a helium nucleus with the release of two protons and 24.7 MeV of energy. So here a total of 1, 2, 3, 4, 5, 6. 6 protons are consumed. But finally, as the product, two protons are released. So we say that the proton-proton cycle involves the fusion of 4 hydrogen nuclei or 4 protons to form a helium nucleus with the release of 2 positrons, which are released here, 2 positrons and 24.7 MeV of energy. Now, in stars which have a hotter interior than the sun, the carbon cycle is the predominant process for the production of energy. Here, a proton combines with C612 to form N714. This N714 releases a positron to form C613. It is N713 here, which releases a positron to form C613. Now, this C613 combines with a proton to form N714. This N714 again combines with one more proton to form O815. This O815 releases a positron and forms N715. N715 combines with the fourth proton to form a helium nucleus and a carbon nucleus as in the beginning, C612. So in this process, a total of 1, 2, 3 and 4. 4 protons are involved, 2 positrons are emitted and a helium nucleus is given out together with the release of enormous amount of energy. And carbon acts something like a catalyst. It is there in the beginning and it's returned back at the end of the cycle. So this is the carbon cycle. Here again consuming 4 protons and releasing 2 positrons, a helium nucleus and enormous amount of energy, which is here too the energy is 24.7 MeV of energy. Now what are the conditions required for nuclear fusion reaction to take place? One is the temperature must be extremely high. So such high temperatures are required to overcome the repulsion between the protons and for fusion to take place. As you know, the temperature inside the sun is about 15 million Kelvin. So such high temperatures are required for fusion reaction to take place. So fusion reactions are also called thermonuclear reactions because it requires high temperature. Next, it requires high density. It is to ensure that the collisions are frequent. And lastly, there must be a large reacting mass, such as that in the sun, since much time may otherwise elapse between the initial fusion of a particular proton and its eventual incorporation in an alpha particle. So the three requirements are high temperature, high density, and large amounts of reacting mass. Now we go on to the formation of heavier elements in the stars. That is, after all the hydrogen in the core gets converted to helium, then the gravitational contraction takes place of the core. The gravitational contraction of the core takes place and its temperature rises to about uh, 10 raised to 8 Kelvin. Then helium fusion begins. Helium fuses to form heavier elements like carbon, oxygen, magnesium, neon, etc. I've shown a few of these equations here. How helium fuses to form heavier elements. Now, heavier the star, higher the temperature of its core and larger the nuclei formed. This process continues till iron 2656 is formed. After that, the heavier nuclei are formed by neutron capture process followed by beta decay to maintain this N by P ratio or to maintain the stability. In this manner, nuclei as heavy as bismuth 83209 is formed. Finally, when a very massive star reaches its end, the end of its fuel supply, its core will collapse. A violent explosion will follow that appears as a supernova in the sky. So, here we have discussed how the nuclear fusion reaction takes place in the sun and it is responsible for and how it is responsible for the release of enormous amounts of energy both in the sun and in the other stars. So I hope this session is clear to all of you. If you have any doubts, please do contact. Thank you.